Hello. Today we will be going over functions, primarily involving how to access any elements inside of them and any ways to organize them. We're going to be starting off with partial and total functions, the broad definitions. In partial functions, for every member in A, there's at most one element in B. In general, the word function refers to a partial function. A total function works in every member in A, there's exactly one element in B. They're very similar, so the main thing is for each element that they have, there's another element. One-to-one correspondences work in the same way. They're also known as bijections. Here we have f of A with little a, as well as f of B with little b. And for every element in A, there's an element B in B such that f of little a equals little b. Simple. For every little b in big B, there is some little a in A such that f of B equals a. So they're similar. For no b in big B, there are two elements in A such that both equal b. So the main thing to take from one-to-one correspondences is that whenever there's anything in element A, there's going to be something similar in element B. So if there's only one element in A, there's one in B, 4 to 4, 3 to 3, 2 to 2, and so on and so forth. Now we're going to move on to function operations. The most common operations on functions are as follows: insertion, deletion, and lookup, otherwise known as search. We're going to use football teams in order to show these functions. So, if we have f of A, little a, represented by Dallas Cowboys, and f of B, little b, represented by the Patriots. So first we're going to do insertion. Here we have AB such that f of A equals B. And we're going to try to insert C. Since this function already has f of A connected to B, C won't be able to fit, so it gets deleted since f of A and B came first. And finally, we have search, otherwise known as lookup. Here we have f of A and f of B as well as their ordered pairs. What we're going to try and search for is a new value, C, denoted by this hockey player. Since C doesn't already exist in our f of A and B in the elements, it gets returned by a special symbol that will show it as undefined. Next up are linked list representations of functions. As you can see in the code, a linked list is a collection of nodes that are associated with each other with a preceding node that has a pointer to a following node. The first node is always the head in the elements. It organizes data, whether alphabetically, frequently used, etc., in a non-static manner. Next, we have vector representation of functions. It is important to know in vectors that the function either be a total function, all the hobbits, or just the range must include a value that can be interpreted as a no value, such as Bilbo there. We can associate an integer constant with each element in the domain and range using enumeration types, our enumeration type being the picture of all the hobbits. So we would do enum hobbits, then to Bilbo, Sam, and Frodo. So this declaration associates 0 with Bilbo, 1 with Sam, and 2 with Frodo. You can also declare an array, such as int shire.
Over here we have a table. We have our hash table for our hash browns. And now to place the hash browns on the table, you need a hash function. So we're gonna have a piece of data associated with each hash brown, which we can call x. And it's gonna be, for our hash hash function, which is going to be mod 5. We'll determine where in the hash table it's going. So we're going to have our first hash brown. This one's going to have a value of, I don't know, 11. So 11 mod 5 will give us position 1.
Mm-hmm.
So a piece of data, our hash brown, will go in the hash table position 1. So that's the hash function.
Moving on to the efficiency of operation, the main goal of this is to use as little time as possible in accessing the memory. For linked lists, you move from the head node to the destination node, which will take up to n times. For vectors, it's a constant since you will try to jump straight to the node you're looking for, but it isn't as flexible. Hash tables are similar to the vector, except it uses a hash function to calculate where the data is located. Thank you for watching. We hope you enjoyed our function overview.
And his name is John